everybody. Appreciate being invited to be here and kind of share some of this with everybody, and kind of gone to quite a few of the meetings previously, and it's been extremely informative and fun, which is great. That's why I keep coming back. And let me give you a brief introduction. Again, my name is Christopher Searles. So I work with Eaton Corporation. I've been with Eaton for 21 years now. 21 and a half actually, but who's counting? So my official title is Power Management Account Manager of the Northeast region for the United States. So what that means to the layperson that doesn't, follow along with all the Eaton acronyms and names is, so I am the sales and marketing resource for our power monitoring group for the Northeast region of the United States. So I cover from the tip of Maine down to Virginia and out to Pennsylvania. So that's pretty much my territory. So any customer, internal or external, that has an opportunity for power monitoring in the electrical side mostly, I get involved, site walks, customer visits, demos, quotes, closing orders, all that. So I'm a sales and marketing resource mostly there. So having spent my entire career in the electrical manufacturing / electrical services group, I have a little bit different perspective probably on a lot of stuff than most of the people in here that are more in the building automation and control side of it. But there's really a lot of similarities to that, and really the tie-in right now is metering and metering devices, where we get a lot of cross communication between the two types of systems. So I thought that's what I'd kind of focus on and kind of go back and talk about the beginnings of power monitoring and industrial communication systems, and kind of explain how the influence of BACnet, or the prominence of BACnet now and some of the BAS systems has really affected the electrical manufacturing side as well. How we go to market, how we design our products, what types of products we're coming out with. So again, I've been with Eaton for 21 years, so a lot of my lineage is the old Westinghouse, Cutler Hammer, Eaton. I mean, that's kind of what I know. So if some of this stuff looks like it's kind of based around that, that's because that's where my background and knowledge is. So back in the, going back to the 90s, early 2000s, most power monitoring systems were proprietary in nature, which basically meant that each manufacturer was kind of developing their own protocol, their own infrastructure, their own, architecture. It was all hardwired communication. So it was pretty much, you had your building maintenance manager, or your engineer at the facility or whatever, had the workstation under his desk, running our software. Everything was hardwired, daisy chained back, came back into the workstation, and then we'd load our software and we'd be able to bring in all the meter data. So that's kind of where a lot of the power monitoring stuff started. Of course, it was 9600 baud. Third-party integration was very difficult, if not impossible at times. And we were able to put many devices on a single run, but multiple protocols weren't supported, and only one master could pull that. So, if you think about that, it was all one tied up, nice little neat system, came into a head-end computer. There was really no user interface to speak of in the early days. It was pretty much just tree view and tables and bring the data in. And any kind of data sharing, the extent of that would be exporting data out in CSV format into an Excel spreadsheet. So the reporting was whatever you could do in Excel. That was kind of where we're at. So, that goes back to, like I said, the early days of power monitoring. So, back then, and going back like 15, 20 years, 90s, early 2000s, the EPMS was mostly electrical, all electrical, and the BAS was mechanical. And there was a lot of separation there. Very little, if any, data sharing, and the two systems kind of ran independently, and everybody kind of stayed in their own, and everybody was kind of happy at that point.
I'm Mike today.
Unlike today, where, well, as long as they keep buying a little bit of EPMS, I'm still happy. So there was some, I mean, why did they do that? I mean, it was technology driven, right? I mean, that's the technology they had. Everything was serial. It was just kind of cutting edge back in the day. But so there were benefits to that, though, and there were some technical benefits. The long serial runs, and again, if anybody that knows, come across a Westinghouse PowerNet system, 10,000 feet. I mean, you could run blue hose, twisted pair, 10,000 feet. You could T-tap as many T-taps as you wanted, 200 feet. The cabling was extremely noise resistant, so you could run in the switch gear. So, I mean, there was a method here, right? I mean, they didn't just do it. I mean, it worked. It worked well. I mean, if you wanted to add on some equipment to an existing system, all you had to do was find a piece of that blue hose, cut it, splice it, run it over to your new stuff, and it would run. I mean, there was a lot of reasons for that. Now, the commercial benefit was obviously there's a competitive advantage on future projects with customers. So, I mean, when you look at why this was, beneficial or whatever else, I mean, if you had a system in place and it would only talk to your equipment, then anytime they were going to upgrade or replace equipment or add on, I mean, they had to have the same manufacturer equipment to be able to communicate to that. So, I mean, a lot of the manufacturers, that was the same situation. So that was an extremely competitive advantage to having that system. So how did that relate to metering devices back then? So really it was digital, right? We were starting to move away from the analog, volts and amps, and the electromechanical kWh meters, that type of thing. So it's kind of moving in that digital direction. The meters were starting to develop a lot more functionality in the power quality realm, waveform capture, that type of stuff. And a lot of that, especially waveform, was extremely difficult to integrate into the EPMS software systems that were out there, to use third-party software, Comtrade Viewer, or something like that, to do that. And the protocols were still very slow, serial, and you had to add additional hardware to make that communicate. So, I mean, it wasn't plug and play. If you wanted to add something in, there was usually other hardware that you put in the field in order to bring that new device into your system. So it was costly, a lot of points of failure to do add-ons. And you were really limited to real-time metering data and trending reporting, like I said, mostly whatever you could export to Excel. But it was starting to provide some work for the facility managers, right? Finally, they had some insight into their electrical systems. Instead of just knowing that the lights are on and taking maybe monthly manual readings of kWh, and have the electrician go around and write stuff down. It's like, hey, we can pull this stuff into a server, export it in Excel. This is great, right? So there was definitely the beginnings of some kind of the customer base was starting to really get excited about this and realize the power of it. Most manufacturers back then maybe had 4 to 6 meters in their product offering. It was really basic, had a couple on the low end, a couple on the high end, a couple in between. There wasn't really a lot of options there. They were all the same protocol. Like whatever they were using, that was limited. Again, the closed proprietary network. The other thing was there wasn't a lot of standardization going on. So I mean, when you did do one of these systems and put in some kind of hardware to communicate, a lot of times it was an IPC with the software could be loaded on, and sometimes not. There was no real standardization to how they was put together. So that's where we were. So hopefully I give you a picture of where we were back. And like I said, this is probably about. I was going to put dates in this, but honestly, it's such a fluid. It was really the 90s, early 2000s. So what happened next? Well, the IP age, right? All of a sudden, it's like, wow, Ethernet. This is great. Customers no longer wanted those proprietary networks. They started realizing that they weren't really beneficial to them in the long run for many reasons. So they started developing. The other two, they started to develop their own networks in the facilities, whether they were dedicated to industrial communication systems or whether you're just using their building network for communication. And I think most of you, probably everybody in this room that's done any kind of communication network knows there was those few years where getting IP addresses was almost impossible. Nobody wanted to let you use their network. So there was a transition period there from that again, that workstation under the desk to let's put a server in a rack, right? So this is kind of where that period we were kind of going through. But what that did though is the software system started to evolve as well with the meters, because the meters got smarter as these networks developed, as you started getting more. It was all IP driven. The software went to web based, and when you need more of a server or web based network, so of course that opened up a lot more. Once you got the server on the customer's network, and once you got once you were able to get the buy-in for that, it made it a lot easier to bring in other equipment. So you might have just your electrical switchgear on there, but then if they had a UPS or they had a generator, all you really needed was a data drop and an IP address, and you start bringing some of this stuff in. So the hardware was evolving, the software was evolving, and really the customers started moving towards their utopia. Single pane of glass for all systems. I'm sure everybody's heard that in here, right? I want everything on one pane of glass. And I call it utopia because most people don't ever get there. It would be fantastic if you could, but because some of these systems, they all have they do things a little bit differently, or they have strengths and weaknesses. It's hard to get that one pane of glass to do all things that the customer needs. But that's where they're all trying to head to. And that was driving a lot of this. So what did this do to the electrical manufacturers, right? So this whole industry is changing, and I kind of talked a little bit about the competitive benefits of having these closed proprietary network systems, and now it's all going to change, right? Now all of a sudden the customers are saying, well, we don't want that anymore. We want open, we want data sharing, we want to be able to see it all in one pane of glass. We don't want to have 4 different systems. The other thing that we saw a lot of is standardization on technical equipment, whether that's protective relays, metering, PLC controls, and the switchgear. They all wanted to standardize. They might have liked a certain manufacturer's protective relay, but somebody else's metering device and somebody else's PLC. And they didn't want, so for the manufacturers, we had to support this, we had to change the way of thinking, right? Because it was no longer just like, let's load it up with whatever meter we want to give the customer. Now they're telling us what to do. So if you want to sell the electrical switchgear, which in that business, that's really what the goal is, right? To sell the gray boxes. So the manufacturers had to somewhat acquiesce to that, to the demand or risk losing market share. And so of course what that led to is they wanted easy integration of these devices as well. So now you get the evolving manufacturing cycle or engineering cycle where they're being specified third-party equipment, but yet their EPMS can't bring that in easily or reliably. So, what that did is it forced the power monitoring systems to kind of evolve with that market as well. And as I said, it kind of makes sense. You get OEM metering that you're putting in, or in relaying that you're putting into your equipment. And, there's a spec out there, 260913, the EPMS spec that goes out. And it really would be kind of awkward that the manufacturer would take an exception to the equipment that's in their own equipment. So a lot of times we're bidding along with our equipment, we call it attachment orders. So they're bidding an electrical equipment, and part of that's an EPMS system. It's a little awkward when the EPMS from the same company is taking exception to communicating with devices that's being provided by their own company, right? So it created this whole okay, we got to figure this out and kind of solve this little mystery of third-party communication. So that's really what drove the electrical manufacturers into this open protocol situation where they had to open it up. It was no longer acceptable to be providing stuff that was proprietary in nature that nobody else could communicate to. So the adoption of that also allowed for a lot of other technological advances. Allowed multiple protocols to reside in the same bus, which was not possible. And a lot of these gateway devices and meters could support multiple protocols over Ethernet simultaneously. So obviously that's going to reduce the cost of the system, improve the reliability. So that's kind of like the end goal. So that's kind of what drove a lot of the changes in the EPMS world. So again, as EPMS is evolving, of course, the building automation systems are doing the same exact thing, right? They're taking advantage of these same advances in technology, the software being web-based and everything else. So they were evolving in a similar fashion. They also found themselves a lot of times in an advantageous position because most of these facilities had some kind of building automation system, whereas EPMS is a lot more, a lot less market-based than the BAS. I mean, almost every building's got some kind of building automation system, whether it's for their cup or just building controls or whatever it is. There's something in that building, but very few facilities really had that true EPMS system, unless they were either a data center or mission critical, or just saw the need for that type of a system. It was not quite as much of a thing. So they definitely were in an advantageous position. So they already had insight to the customer's critical equipment through the BAS system. So the one piece that they were kind of missing was that critical electrical load data. Right? I mean, they had all the mechanical space covered, they could control, they could do all kinds of, they had a nice GUI interface. The only thing they really didn't know was, well, what's the building load? What's the electrical load data? So that was kind of the missing piece. So it became a really short putt to start integrating this electrical data into the system. Just taking main meter data or whatever else. And this is where that overlap started to take place. And then the real big thing there is the data analytics and predictive analysis tools, right? As we're moving and progressing now, I mean, that's really the differentiator that you have. It's getting to the point where anybody's able to pull this data in. Then what do you do with the data, right? That's kind of been a topic for the last 5 or 6 years, right? You get this big data, it's all coming in, it's all stored on SQL. It's like, great. What do I do with it? Nothing, right? I mean, maybe do a little reporting or something else, but so I know there's most companies are trying to work on the analytics now and come up with, well, what do we do with the data? How do we process it? And part of that whole picture now is having the whole facility picture, not just the mechanical space, not just the electrical space. It's starting to really evolve and come together. And then, of course, it wouldn't be a presentation if we didn't talk about security somewhat too. So. Cybersecurity in the OT space, I know everybody's kind of working on that. It's a big thing. I mean, people are starting to realize, customer base is realizing that you hang these devices on your network, and there's some vulnerabilities, and so that's another opportunity that's evolving in the BAS and in the EPMS world, for that matter. That didn't come out so well with it. Intersecting circles, trust me. Yeah. The irony was it was darker and I liked it because I thought it was too dark. So, PowerPoint skills, yeah. You can tell I did this one from scratch too. This wasn't my cut and paste job. I have 100 of them on my laptop. I'm like, none of these help me. So I guess I'm starting from scratch. So, meter technology progression. Right, so most of the manufacturers, as I just discussed about opening up the protocols, the first thing they did was go to Modbus RTU and TCP/IP, and that kind of partially solved the problem, right? Because what that did, it allowed in the electrical realm, the EPMS realm, it allowed somebody had one OEM EPMS system, it allowed another OEM manufacturer to sell switchgear into that, and meters or relays, and everybody could tie everything in. Everybody was happy, right? The customers were really happy. So that kind of solved that problem. But what it ignored a lot of the BAS space, right? Because a lot of the BAS was BACnet based, so it didn't really help. The only way to accomplish that was through these protocol converters, which are, introduced another layer of cost and potential failure. You'd have to bring in, if you had a Modbus device, you'd bring it through a protocol converter, convert to BACnet, bring it in. So it worked. It was, definitely a solution, but at the same time, it did add a little bit, another layer in there. It actually made it a lot more difficult to integrate versus, plugging and playing and getting it, direct out of the meter itself. So then what happened is the manufacturers they started offering a limited portfolio of BACnet capable devices, And this is probably going back 7 or 8 years, I'd say, that I started seeing a lot more BACnet devices, at least coming out of our factory, and allowing them to directly integrate in the BAS system. So BACnet meter hardware today. So now most electrical manufacturers we offer a full line of BACnet capable products. You know, from the lower end, we have branch circuit monitors. Low end just energy metering, and all the way up to the high capability power quality meters with waveform capture. All offer BACnet, both MSTP and IP output options. So we're really completing that whole integration of bringing the electrical and the mechanical space together as one. So especially on the hardware side, and this has definitely been happening. Again, it's probably been 7, 8, 10 years. I don't know what the feeling in the room is, but that's what I'd say when I started seeing a lot of BACnet. And I just remember going out to a couple sites locally here and being like, all right, how do we tie this in? Where's the IP address and where's the, So it was a little bit different, but definitely something that we've kind of gone over that hump. Gateway devices as well. So most manufacturers, I think probably all of them now, they have a gateway device. So a lot of times our trip units are still serial, so that are wired out. So a new piece of electrical switchgear, you got the main metering, but then you got all the trip units and the breakers come out and communicate as well. And all the gateway devices now also have a BACnet setup capability as well. The hardware has become very smart, all web pages for configuration and being able to go in there and pull data. There's data storage, data logging. So as most people in here are probably well aware, the metering technology has really advanced quite a bit. So this is again bringing that overlap between facility EPMS and the BAS even closer together. And now most manufacturers have 12 to 15 meters.
Where in the specs do you see this kind of stuff called out? And the integration language, where does that appear? The electrical side, BAS side? Where's that integration spec occur?
I see it a lot on the electrical side. And it will say, it'll be usually a one-liner, must tie into BMS system. And that's usually all I'll see. And a lot of times, so what we do in my world, so we have multiple ways of doing that. We can share data, we can bring them out of the meter, but we also have software gateway drivers that we can take, so we could bring into our EPMS system, and we can now open up our EPMS system and send whatever data to another system, whether it's BAS, a DCIM in a data center environment, or whatever that is. So we can do it that way as well. Or you can go right to the gateway of the metering device and pull it, depending on the, whatever.
Do they ever spec what the value proposition is for that
No.
data? What you transfer, or just the system
No.
to be able to communicate?
Right. That's all I see is one line, must communicate to existing BAS systems.
That's all, right?
Yeah, that's all there is. So it's,
But what you'll end up with is two identical networks running the building until the final day, where Chris and I will have to say, he'll say, I have to tie into you, and we've got wires run next to each other,
Right?
where it could have been, architected differently.
That's
Is it fair to
absolutely
say
right.
that when you read that needs to interface to BMS, you automatically translate that to BACnet?
No, that's not fair to say at all. I usually don't have any.
Okay.
At this point, it's a construction project typically when you're talking about a specification. So it's not an existing facility, and it'll just say BMS. So for me, at that point, it does not really matter because I get, like I said, we have a gateway, what we call a gateway driver. Again, it's just a drop in on our software that opens up every point we pull in to a third-party system. We have one for BACnet, and we have one for Modbus, and we have some other ones as well for other protocols. So at that point in the quotation process, when we're trying to go through the specification, it does not matter.
Jim, I've got 3 recent examples. One was a big sports stadium project done with a competitor of yours.
Yep.
Most of the requirements were in the BMS side,
Right.
but they specified OPC, which was ridiculous, and that wound up being disposed of. Another one was a university again with a competitor. That one was interesting because the consulting engineer actually came to us and said, what do you want in the gear so you can do your job? Okay. We worked with the company, and they were even smart enough to put fiber optic cabling in because this gear was out in some areas we're concerned about, voltage gradients. But the last one, which was an absolute crap show right now, there was very little. There was a piece for the electrical suppliers, but they put this paragraph in our contract, not the spec, that said provide interface to double-ended unit substations, quantity 12, didn't go into the protocol, didn't go into anything. These guys didn't have a lot to go, and we didn't get to talk. They just heaved stuff at it, and then we got told, oh, it's your contract. You make it work.
Right.
And we unraveled it, but what we saw was it wasn't well defined. You don't see good definition. That's the answer. I can tell you, I don't see it. Could be a one-liner, could be a whole paragraph for me, one line for him, but nobody ever gets together.
That's the consultants a lot of times. It's just a quick cut and paste. Or whoever's working with them.
Maybe that's a good opportunity for this kind of community to get together and, put a white paper, even a full-page white paper together that we can tuck up the backsides of the consultants. Save everybody a lot of heartache and add a lot of value up front.
Yes, I'd volunteer to help you with that. Save me heartache.
My experience is usually it's the BAS is what drives it, and we're just feeding. Cause again, we've kind of been reactionary in this process where we're coming, and we'll just feed them whatever they need. But one of the cautions when you're talking about metering hardware too is depending on, and this happened a few times locally. I'm sure some people might have experienced this. When we first started to come out with this, and even still now, there are some meters that are configurable. So, if you get one of our high-end power quality meters, you can go in and say, I want it's BACnet or it's Modbus, right? Or whatever else, whatever protocol you want output. But there are, especially like panel meters and stuff like that, the lower end, you order it as a BACnet meter or you order it as a Modbus meter. And if you get the wrong one, you're replacing 72 meters in your building because it's not going to work. You can't convert it. So just a kind of a word of caution too, then that's kind of probably some of the stuff. It's like, okay, we're BACnet, you get Modbus meters, what gives here, who made the mistake, right? So yeah, there's definitely an opportunity there for it to come together and a lot more. And again, that's kind of the point of this whole thing is that this started separate, it's all coming together now, and there needs to be a lot more cohesion between the two systems for sure.
I got a quick question.
Sure.
Do you find that today more people are ordering IP-based electrical meters, or are they ordering still the MSTP?
IP based.
So your blue cable network is kind of not being put in new construction?
Mostly no, correct. We still see, so what happens typically is we're seeing the trip units being wired out serial to a gateway, and then you'll have, the meter will be Ethernet, and you go to an Ethernet switch in the gear, which usually people throw out and bring a drop to each one of them anyway. If I had $1 for every Ethernet switch so I get thrown away. But I guess sometimes we'll see the spec where they'll want a meter on each breaker, not just the trip unit, which kind of crazy now because the trip units are pretty solid with the metering. But in that situation, we may opt to, unless it's specified, we may opt to run serial back to the gateway again. We'll use our metering product that's, Modbus RTU or whatever, and bring it to a gateway. Just cost savings or whatever else, depending on it. But the short answer is, if we can use Ethernet on a relay, a meter, whatever it is, we're using Ethernet. So, and customers have relaxed that. We have this huge trunk of Ethernet cables coming into a line of a switchgear, right? It used to be a big deal to get a block. Now they're like, how many do you need?
And because that's galvanically isolated, there aren't that many worries about the low voltage stuff running around in the switchgear. How's that?
Yeah, no, it's. We do use shielded in the gear. We'll use shielded Cat 5 or Cat 6 or something for the for that network side of it. But as far as the drops, normally it's in a spot, in a control spot anyway, where it's dropping in. It's not really running around near any of the larger loads. So we haven't seen a lot of problems with it. Occasionally, something will prop up depending on the configuration. But like I said, we use shielded in the gear itself from the factory as a standard.
Right.
So in conclusion, and a lot of this is we've already kind of talked about, but as hardware technology evolves, EPMS and BAS are just going to continue to. This is going to continue to blur, right? It's going to definitely. The software technology advances and contributes as well as the hardware. It's the whole thing. As everything advances, it's almost redundant in most situations to have both. As the BAS, there is some. EPMS typically we pull a little faster, maybe store the data a little more, but I'm sure those advancements on the BAS side are coming up too. But, so it's getting real hard for me in my world to kind of, carve that little slice of pie out for. So hoping I can get another 10 years out of it.
If you were to look at the spread between Modbus and BACnet that you sell now, what's the spread?
Metering,
Yeah.
somewhere between 75-25 and 80-20, probably Modbus. So
How about switchgear?
yeah, same.
Same.
Mostly, probably maybe even a little bit more, because typically in the field, if you're thinking of like a commercial building, it's a lot more prevalent or a lot more possible that it's going to be BACnet, right?
Industrial.
In industrial and switchgear, it's probably going to be Modbus for us. Like I said, a lot of times we'll take that as Modbus and then we'll go through a gateway device and output BACnet anyway. A lot of times we don't know, so. And really the key to this thing too is the middle bullet. As is almost always the case, these changes in technology and attitude are driven by the consumer, right? I mean, really that's what drives everything for us, is like, what does the consumer want? And then we all kind of react to that and try to meet those needs. So that's what kind of drives the behavior, probably from everybody in the room, right? We're all here we're all salesmen or salespeople in some format. So it's all about whatever the consumer wants, whatever the desire is, that's where we go. So, and that's typically different market verticals as well, right? So you always got to figure out like what market vertical you're trying to target. So. Anybody else have any other questions?
Do your high-end meters export? Have you come up with a good way to export the waveform captures of like a surge event or something? You capture. I see. Your fancy meters definitely capture
Yep.
that. But
So I guess I'll answer that. I'll try to stay somewhat vendor agnostic here, but yeah, no, with our meters. And with our software now, we can direct pull it in from the meter to our software. So,
but it's still trapped in your.
Yeah, but all you got to really do is hit the IP address of that meter from the outside, and
Yeah.
you can pull it out. You don't need any special software. So
It'd be slick to see that like stored in a BACnet trend log and be able to pull it out that way.
yeah, that's like I said, a lot of this stuff's kind of progressive. But yeah, in the higher end, like for us, it's the PXM 4000, 6000, 8000 devices. The sampling rates are off the charts now and everything else. So it's certainly a lot easier to do waveforms and stuff like that now than it ever was.
So you kind of mentioned early on in your presentation that people are moving towards the analytics or predictive things. What things do you see coming out in the electrical metering world for analytics, and like what are we doing with that data?
Yeah, so when you talk about the electrical, more like the power monitoring stuff, right? Like the meters have onboard logging and data, but for the most part, people are going into the meters when there's an event to look at stuff, right? They're going to go to the web page, hey, I had a problem, might pull a waveform capture, but they haven't progressed to the point where the meter itself can do a whole lot of like data logging and analysis. But if we have an EPMS system on the electrical side, right, and we're bringing all the data in, then the main thing we're trying to do is reporting right now. So we're trying to bring that into whatever type of reporting the customers want. We have a whole reporting suite, whether it's tenant billing, PUE for data centers, energy summary, capacity summaries, your typical reporting, and that's all like in a canned format for the most part. So we're really concentrating on that, but we're also working on some pretty cool stuff coming up too, where we're going to start finding other ways to pull that data out and open that up to the customer and let them kind of decide what they want to do and come up with. So it's always a struggle, right? We pride ourselves on, our software. We have 1 second sampling. We save all this stuff to SQL. We have a high res database. You get all the data you need, right? What do you do with it? Right? That's always the hard part, is getting the customer to really go in and do something with that. But I probably didn't answer your question, Gray. All I know is it's basically now it's canned reporting is our typical output that we're giving the customer, and trying to develop those types of reports that the industry's looking for. And different industries as well. Like I said, commercial is going to be looking more for like tenant building, whereas the data center wants a PUE report, and we're trying to work that. But there's also, we are looking more towards the bigger picture of what else can we do that's not so canned, right? How can we make this a lot more versatile? So
with all that you're doing today with the, I don't know if it's a cloud, I guess it's like you have web servers at each location, or you send those reports to your customers monthly, or?
That's a great question.
So like the
yes,
security aspect of that, third-party penetration testing, like where is that data stored? Is it backed up? Is it, different types of government, commercial, industrial, they all have different types of
So
regulatory compliance policies.
almost all of our systems, again, I can only speak to what I know some of our competitors do it differently, or a little bit further advanced in like the IoT cloud stuff. We've been a little hesitant to do that for the reasons that you just brought up. So almost everything we've done to date is on-site server. So the customer provides us either a server in a rack usually now, or a VM, a virtual server, a SQL instance, and they control that. They have their own database administrators and whatever else. So they take care of all that for us typically. So we don't have to worry about that too much. We are very interested in, like everybody else, in the IoT, the cloud, and we're trying to figure out what that's going to look like. And we're just also with the cybersecurity. We have our own, like we call it a COE, cybersecurity COE, that everything we release now, hardware, software, is going through cybersecurity first, which slows the process even more. So
IoT, the word, it's just so
so
it's like the trend right now. It's like
well, it is, and
very overrated.
so being a larger corporation, we're not obviously the largest, but we don't move fast, and that's sometimes good, right? So it's slow and steady, and we're definitely risk averse. So when you start talking about stuff like that, but at the same time, we're trying to react to the marketplace. We're trying to find out, especially in the commercial space, with a lot of these like tenant billing monthly reports, like you brought out, they don't have the on-site expertise that say a data center would have, right? A data center, they get somebody that's looking at the system, mining the reports, doing what they got to do. But commercial building, it's like, hey, how much do I bill each one of these either commercial or residential tenants every month? That's all they want to know. And that's like more of a cloud-based, with an edge device type of thing. So we're looking at all that, but right now we're still almost entirely, on-site server-based data storage. All right. Well, again, thank you very much. It was.